Hi, everybody. Depending where you're joining, good evening or good afternoon. Uh, Me and Rosaria are joining from Europe, so good evening to all of you. And Andrew is based out of West Coast, so good afternoon. Welcome to today's event live stream. We are hosting on why AI needs data engineering. Basically, today's event is focusing on how everybody talks about AI these days, but how is AI going to be if the data is bad? Today's event is dedicated to the data before AI and why AI needs a good data to obtain this. Just to quickly introduce our today's speaker, Andrew Matson. He's a tech evangelist at Dreamio. He has a extensive team leading experience within the finance and education sector. And our second speaker would be Rosaria Filippo, and she is a head of evangelism and basically expert in data mining, machine learning, reporting, and data warehousing. On top of it, she's author of this mentioned book here, and basically we will be having two of these talks from the mentioned speakers. With that, I would like to give the stage to Andrew, and maybe you can share your screen.
Wonderful. Thank you so much for the introduction. I'm excited to be here. Let me go ahead and bring up the presentation. And I think we've got a really good 1-2 punch today because I'll be covering at a high level, does data engineering matter in the age of AI? And then Rosaria is going to really drill down into the data engineering aspect. And so again, thank you for the introduction. I'm Andrew Madsen, an evangelist at Dremio, data lakehouse company. And for those at home, Dremio did write the book on Apache Iceberg. If you'd like a free copy, scan the QR code. I'll leave this up here for a second. Apache Iceberg is what enables data lakehouses to be able to consolidate data and really enables a lot of the AI and machine learning. We're really excited about that, and we've seen Apache Iceberg growing quite a bit. For a while there, it was like, is it going to work? Is it not? And then we've seen Databricks acquire Tabular and are integrating Iceberg into their processes. And we believe that that's a strong indication to the market that Iceberg is here and is going to be the standard to stay. If you'd like to connect on LinkedIn and continue the conversation, this is a link to my LinkedIn. Just as a matter of background, I've led data teams all over the place, mostly in higher education and financial services. On the side, I'm a professor of data science at a few different places. And then also we can connect on social media, on LinkedIn, and then my podcast on YouTube, specifically around these data topics. Let's jump into it. So I think we can all feel the AI revolution. There's unprecedented use of AI. We're seeing breakthroughs not only in generative AI, but also in machine learning, deep learning, natural language processing. And companies now more than ever are really at least investigating the use of AI. Individuals are seeing AI reshaping the way we interact with technology. We're finding ways to automate processes, make decisions. And the rise of AI powered applications from self driving cars, virtual assistants has really captured the imagination of what could be possible. And as we mentioned, at the heart of AI is data. Data is the fuel for AI's capabilities. And ensuring that we can have really high quality data is going to probably determine how well our AI programs work, first of all, or even succeed. It's going to enable our machines to learn, adapt, and make intelligent predictions. We've seen, there's a quote from Bill Gates on here, but there's quotes from almost every large business leader. In fact, recently we saw JP Morgan announce their use of AI for not only customers, but they're building an AI bot for their employees to use to really help optimize their processes. And in the future, we're seeing in recent surveys of executives, 78% of executives believe AI will have a high or extremely high impact on driving innovation. through brainstorming, through reimagining what's possible. 56% of those executives believe AI will increase productivity by at least 11% in a 2024 survey. And KPMG predicts that generative AI revenue will grow to 1.3 trillion over the next 8 years. So it's a huge opportunity. And I think that's why we're seeing a lot of boards give a top down directive of, hey, please do AI. We don't want to fall behind. And please figure out how to do it effectively to not only unlock new capabilities for our customers, but also for ourselves. So AI, I believe, is here to stay, and surveys all over the place of executives from many different sources really are rethinking what does the future of work look like. And the organizations are really showing that with their dollars, right? We can talk all we want. We've talked about lots of concepts over the last 15 years, some exciting, some not as exciting, that seem like they're going to really revolutionize data, but then they don't get funded. But companies are voting for AI with their funding. So we're seeing at 63% of organizations that are at least experimenting, actively experimenting with AI and building out their programs. And the 13% in this recent survey from McKinsey are already implementing. JP Morgan, Arizona State University, those are early adopters, and they've been early adopters of technology as part of their history. They're implementing, and I think that is causing a lot of companies to follow suit, and they don't want to be left behind in the AI revolution. So there's incredible opportunity here. But as we noted, it's all about the data. So from MIT, 72% of CIOs said that data problems are the most likely factor to jeopardize AI ML goals. And if you're an individual contributor or a data leader, I think you see that and think to yourself, yeah, definitely. Like that is 100% right. Like maybe we're struggling to get our data quality to the point where we can do BI. And now we're trying to do AI on top of that. So in the AI driven landscape, where algorithms and models are taking center stage, really the backbone is going to be data quality. Brian Goldstein from Google believes that it's really supercharging the amount of projects that we're able to do. We used to think in terms of 24 to 36 months for projects back in waterfall days, and maybe now in this time he's saying maybe we can do 30 projects. But if those are all based on low quality data, how many of those are going to fail? And then we're just really a waste of both time, money, and opportunity. Because organizations struggle with data. We've all seen it. I've seen it. Every organization I've worked with, data quality can be a challenge. Many of them have scaled quickly, and then their data practices have not kept up. And we're seeing this with AI. It's difficult to build AI on top of a system that's not really supporting solid decision making to begin with. So, in terms of a data culture, with the CIOs that were surveyed by New Vantage Partners, only 19% had reported that they have an established data culture. I don't think any of these numbers are surprising us. 26% report that they have a data-driven organization. 39% report that they are managing data as a business asset. Honestly, I feel like that's a little high based on the organizations that I've interacted with, because we say, data as a product, for instance, and there's a lot of confusion in the market about what that means. We say data as a product or data products can drive AI, but there's not a common definition across what that means. It's introduced with data mesh, but then a lot of that has now been changed and evolved and become more of a buzz term in some senses. 47.4% report that they are competing on data and analytics. And that's what we mean by a data-driven organization. So less than half of these CIOs are using data and analytics to be competitive in their verticals. And it's only getting tougher for us. It's getting worse, in my opinion, because before we were really using real data. Maybe we bought data from data marts. We were, purchasing data from companies like Axiom, or Snowflake has like a great data sharing capability. But Gartner's predicting that 60% of data for AI is going to be synthetic. That's up from the 1% predicted in 2021. So now we're dealing with synthetic data making up the most part of our data because there's complexity there. We've got privacy issues, regulations, bias, and collecting data. We've seen some controversies around how some of these AI models were trained. Were they trained ethically? Were they trained on data that they were allowed to access? And should they be compensated? And so a lot of companies are now creating synthetic data. And to avoid a data swamp, they need to be thoughtful and careful around that. Adding to that complexity is real-time data. Generative AI and a lot of ML models in general really thrive on real-time AI. If we're doing fraud detection, we should really try to have streaming and as close to real-time data as possible. DataStax wrote a really great article that they partnered with CIO.com about the 3 keys to using real-time data in AI: event streaming data, operational data, combining those with machine learning models, or in our case that we're talking about, AI models. And it's really a difficult task to put on a team and suddenly start trying to stream data if you're currently doing batch or cron jobs. But as companies compete more and more on being able to be quick, reducing the time to insight and increasing speed to product recommendations, to reducing fraud, to having the context window of their AI as up to date as possible. Supply chain companies I've seen are really just trying to stay as lean as possible and have the at the right time delivery, which is a huge amount of data. And not only is it a large amount of data, they're trying to have it real time. A monumental challenge. And what's coming down the pipe? It's coming from the top down a lot of times. It's coming from boards and executives who are saying, we need to keep up. We need to do AI. So what's our plan? We're going to collect data. We're going to try to make it real time. And you guys figure it out. And we're going to have AI at the end. Those question marks is where our heroes, the data engineers, come in. There's been lots of articles written about like, where is data engineering going in the age of AI? Will they be replaced? We saw Devin, who's the software engineer AI, who can do some complex tasks, and are they going to replace data engineers? So it's becoming a thoughtful topic with some of the students that I teach in grad programs in data science and data engineering, even data analytics. They're asking like, is this going to go away? And I don't think it's going to go away. I think it's going to change, because data engineers are responsible for creating accurate, complete, timely, unique, valid, and integral data. And that's the backbone of creating effective AI models. Data engineers are really the unsung heroes when it comes to AI. We look a lot at the AI engineers, even prompt engineers or ML ops. Data engineers are really, they need to be coupled with the AI teams in order to have an effective program. And as data becomes more complex, we see the need for new storage structures. So before we had structured data, which was really feeding analytics. Maybe that was held in a warehouse. We had unstructured data, which really was feeding a lot of ML and AI. And these were viewed separately. They were often not combined. They were used by different teams. Analysts were not going into JSON files and trying to make use of that, even though at the end of the day, we're all trying to make the best decisions possible with the data that we're given, with creating a true customer 360, with trying to reduce churn, with trying to reduce total cost of ownership and optimize product recommendations by using the best data, and maybe it's structured or unstructured. Enter the data lakehouse, right, where we are able to organize all the data through the magic of table formats like Apache Iceberg, which are really powering a lot of AI programs out there. I believe that data lakehouses, especially open data lakehouses, which give you the power of choice across engines and storage and BI tools at the back end, really give you that flexibility of customizing your structure for yourself, for what's best for your business. As an example, depending on where your data is held, regardless of if it's on premises or if it's in the cloud, you're able to combine those, use Iceberg tables. If you're using Dremio, you can use what we call reflections, which are intelligently cached representations of your data, your most used, most important data, so that your queries are lightning fast. You can do your output and your BI with awesome tools like Nime, where you can do low code, where you can do AI, ML on one unified layer. So regardless of where the data is stored, you can access it all through one place. Tools like Dremio enable data virtualization. So we've got a unified access tier, and then query federation, so that it abstracts away for your data engineers, for your data analysts, where the data is specifically held. They just need to access a table, and they don't need to know that the table is made up of 5 different data sources. The engine will be smart enough to federate that for them. And so I know I'm coming up on time, but really data engineers are not going away. They're adapting. The question for a lot of companies is, should we automate or augment certain aspects of the data engineering role? Automation is going to really free up data engineers to focus on what's most important. They're going to be able to engage with business users and stakeholders more. They're going to be able to use AI to augment their coding ability. They're going to be able to automate simple pipelines so that they can really focus on optimization. And so evaluating the tasks, the jobs to be done that your data engineers have, and figuring out, how can we use AI to optimize them? How can data engineers be augmented by automating away some of those lower level tasks that they have? Some of the key aspects that they need to focus on are privacy, ethics, fairness, data provenance, explainability, and security. These are critical for AI to be successful. And who's extremely close to that? Data engineers. Data engineers, when they're detached and removed from these concepts, and they're just building the pipelines without having line of sight into the downstream impact or the governance asks, that's where problems can come in. So if engineers can automate away some of their tasks and then be able to more effectively collaborate with the downstream groups, with governance, with the AI engineers, with figuring out how can we create fair and ethical and models that follow CCPA or GDPR or any of the EU regulations, then they can create effective pipelines. And so with the emerging trends, we're not seeing data engineers go away. We're seeing them become more and more important and upskilling into AI. Their data ops and ML ops skills that they've developed are critical for building out effective AI programs. Strong use cases that we've seen, we mentioned a couple at the top, but healthcare, finance, manufacturing are all actively building out AI programs and enabling their data engineers to be more effective. Data engineers are not going away. They are becoming upskilled. They're becoming stronger. They're becoming closer to the business and to the downstream use cases. So I think that all of us can be excited about where it's going, because AI is becoming more important to all businesses at the higher levels and then at our individual contributor levels. And as we as data engineers upskill and keep up with what's going on, and then use AI to our benefit to automate away some of those lower level tasks that take up some of our time, Then we can use higher level tasks, critical thinking, collaboration with our stakeholders to make more of a business impact. And so if you want to learn more about Apache Iceberg, which is really the open source technology which powers the ability to create a lake house, you can take a free crash course by using this QR code. And this is a 10-hour course broken up into 1-hour increments where it really goes from beginning to end of, okay, lake houses sound great. Unified access platform, not increasing compute, doesn't matter where things are stored. Look into Apache Iceberg. We'll be happy to educate you on that. All right. And I think that's my time. I think that was 20 minutes. And Shantanu, are there any critical questions that you'd like me to address at this time, or should we wait until the end?
I think we can wait. We don't have any open questions right now. Just to remind people who recently joined that there's a Q&A tab at the bottom. You can use that. And if you have some questions for Andrew, we just take them towards the end. And with that, I think, Rosaria, if you can start with your part as well already.
Okay. So let me share. There is a bit of dancing every time I have to do the sharing. So just a second. Okay. Okay, so welcome everybody, and thank you for inviting me to present here. Actually, I wanted to start in a different way, but I actually have a different line to start. So today I was interviewed for, about the jobs, how the jobs in data science are going to change with the introduction of AI. And one of the questions was, which job do you think is the most, let's say, underrated, but yet important in data science? And then, of course, I answered this data engineering, because you can have all the AI you want, all the machine learning you want, you can build all the reports you want, but if the data underneath the whole processes is bad, then you get bad reports, bad models, bad AI responses. So I mean, everything relies on the data engineers. Okay, so since we're talking about data engineering, often I actually get this question and I say, but what is it that the data engineer does? I mean, what is it? I know we talk about data engineering a lot, but what is it? Can you I just take my data from somewhere magically and then I display them in a dashboard, or I use it to train a model? And then it works. Why do we need data engineering? Well, data engineering is actually the development, implementation, and maintenance of all those systems and all those processes that allow you to take the raw data and then produce high quality and consistent information. So it's a bit like, everybody thinks that having drinkable water in the house is okay, is normal, but actually there is a lot of process behind to guarantee that. It's the same with data engineering. There is a lot of applications, a lot of implementation of processes and of systems so that your raw data can become reliable and consistent information. Okay, so there are three, in my opinion, there are three directions, directions on which data engineering is relying. So one is time, one is data sources, and one is information. Time is because when you have to access data, for example, from a cloud, from the web service, from wherever, usually they're available just for a limited amount of time. You rarely can access data for today and from today until the beginning of times. That's obviously not possible. So what you are supposed to do as the first thing that you're supposed to do as a data engineer is to put together the history of the data in your data repository. So the first duty is to concatenate the data from yesterday, the day before yesterday, the day before yesterday, and today, so that you get a repository of the historical data. The second one is the data sources. Of course, even if you want to access the data, not all data is available in only one data source. I mean, you might have some data in a database, some data come from file, some data is available on the cloud, the web services, the social media. Of course, you have, a huge number of data sources that you're supposed to query to collect all the data related to your business. And then the last one is about building the information. So what you collect usually are details. Let's say you collect a number of contracts, but this number of contracts doesn't give you a high level enough information to describe your customer. So what you need to do at the end is to perform, first of all, clean up the data, but then also to perform some kind of aggregation to build the metric that describes your customer. So to move from the list of contracts into the information that describes, for example, your customer loyalty or something, or your patient health, something like that. So what does it mean in terms of NIME? When we want to concatenate historical data, then the node that we want to use usually is the concatenate. We have also concatenate for database so that you can connect to the database, and then you use the concatenate database to perform the operation, not on your machine, but on the database. For the data sources, the other node that we always use is the joiner node. Those are the basics, the basic skills of a data engineer. The joiner node allows you to put together all these different pieces of information from different data sources. However, the joiner node is not the only one, because you need also connectors to connect to all these different data sources. This is a cheat sheet, the cheat sheet of the NIME connector nodes. It's only a subset of the actual connector nodes, but you can see that, we have spent a lot of time into designing different connectors in a way that they look similar to you, so you don't have to think of what's underneath, and they allow you to connect to different data sources. So that means to databases, to file systems, to cloud resources and services, web services, server, and other things like that. So you can download these cheat sheet connectors from the NIME Press web page. You go to the NIME Press web page, you scroll it until you find it. Okay. So then the last piece is how to build the information. Of course, for cleaning, you have to rely on a lot of filtering. So here I put the raw filter node. There are many more in NIME. And for the aggregation, so to build the metrics that describe some kind of habit, some kind of behavior, the monetary value of the customer, you usually rely on the group by node, the aggregation node. Okay, so but this is not enough. We said that data engineering relies on time, data sources, and information, but that's not enough. It has to be, it has to perform all its operations correctly, efficiently, and securely. And that's actually, those are the characteristics that make data engineering such a challenging work. I am not going to talk about all of these features, these characteristics of data engineering, because there is no time. I'm only going to talk about testing and security today. But if you want to know more, you can write me. We have a full course around that. So it's we have a full learning path around that, so that at the end you can become a certified data engineer with NIME. So let's talk about testing. Correctly means testing, and then more testing, and then more testing, and then more testing. So there are many different testing. I took this image from a Medium article. So as you see, there are all possible sorts of testing. But what does testing mean? It means that if I have an input and I have my application, I know what I should expect as an output. So what I do as testing, I put the input, I pass it through my application, and then I compare my actual output with the output I was supposed to expect. So this is in different conditions. So for example, with many data, with not too much data, with only testing the little units, or testing the whole application, or so different conditions, but that's what testing is. So what of all these testing that should be run, those are I think, in my opinion, they're the most important. Of course, you need to develop unit tests on the components, on the different units of your workflow, functional test on the workflow before it goes into deployment, and then deployment test on the workflow immediately after it's deployed, just in case something went wrong, for example, with the path or something. When you move your application from the development environment to the deployment to the production environment. Another important kind of test is the stress test. So, okay, my application is performing well, but is performing well, only with a few data. If I use a lot of data, or if I run many of these applications in parallel, how is it going to perform? The canary test is another kind of testing, so that you move into production your workflow, your application, and then you let it run with low visibility for a while just to monitor if it's going to break. And then, of course, that's not finished. Once it's in production, you still have to keep monitoring your application. There might be data drift, there might be some conditions that change, and your model or your application is not performing well anymore. So the basic, the node that is at the basis of all this testing are the validator nodes. There are two validator nodes. The one is the table validator, and the other one is the JSON schema validator, but they work similarly, only they work on different data structure. So the table validator ensures that a certain table structure and content belong to the input data table. So it receives an input data table, and this input data table is validated to have a certain table structure and to have a certain table content. This certain table structure is taken from a reference table which is specified in the configuration window of the node. The same thing happens for the JSON schema validator, only that it works on the JSON schema rather than on the data table. Another important test, as I said, is the stress test. Here, the problem is not much. So hopefully the application works if you have a reasonable amount of data. But what happens if I have a lot of data? It's possible that your application is going to slow down considerably because you haven't implemented it in a way that takes into account the scalability of the operation. So in this case, your friend would be the timer info node, because the timer info node can measure the time of execution, the execution time of each piece of the workflow, of the KNIME workflow. So this node is going to tell you how long it takes to execute each node in the workflow, and then you can easily find out which are the nodes that are going to be slowed down with the massive amount of data. You can also check if it's a KNIME related problem or if it's maybe an external problem. Like, for example, you connect to a web service, and with a lot of data, the web service doesn't perform, or something like that. And then you can also measure how much you improve your execution time if you make any changes. So the timer info node, remember it, it's your friend in stress test. As a tip, so usually there are different environments that are used, one for development and the testing and for production. So my advice is always to use a testing environment, never to test in production, and the testing environment should be as close as possible to the production environment, should mimic it as much as possible as the production environment. So let's talk about security. There are two types of security. Security about the credentials and the keys that you might want to store in your workflow, and then the security about the sensitive data. So let's see about the credentials. Of course, absolutely don't save any credentials in plain text, especially if your workflow is going to be shared with other people. There is a way to prevent your workflow to accept this kind of command, so to enable the saving with plain text. And this line here in the KNIME.ini file allows you to disable all possible storage of passwords and credentials in plain text. Then how do I handle the credentials? The credentials are usually handled with the credentials configuration node. The credential configuration node encrypts the credentials. So you can store your credentials or prompt the user for the credentials at the beginning, and then the encrypted credentials are going to be passed down into the other nodes of the workflow. So, for example, in the credential configuration node, this is the configuration window, and you can see that there is this option, prompt the username in component dialog. So when the application starts, you get prompted for the credentials get inserted, they are not saved, and then they are passed to the next node in the form of a flow variable, encrypted flow variable. So it should be safe. Otherwise, another way of handling the credentials is when you have to deal with authenticators, for example, to Microsoft or to Google, to web services. In this case, you not only are supposed to encrypt the credentials, but you're also supposed to limit the available scopes, of course, right? So if you want to use Microsoft services or Google services for one thing, then limit the scope to that one service that you want to use. Another way of storing, encrypting the credentials is to use the secret store. So the secret store is available on the 9 Business app, and there you can store your secrets. So that means your credentials, or for example, the API keys or other things that you don't want other people to see. You can have a user secret store or a team secret store. If you use the 9 Business Hub, you know that you can set up teams, and people, they have a space where they can share workflows, information, secret stores, and other things, and they can work together. So you can have then, if you're a user, you can create your personal secret store, but if you work in a team, you can have a team secret store. It has to be created by the team administrator, and all the secrets are going to be shared with the team. So how do I consume the secret once I save the secret inside the secret store? There is the secret retriever node that allows you to retrieve one of the secret from the secret store, encrypt them, and then pass them as a flow variable again to the upcoming, the following nodes down the data flow of the workflow. Okay. So now what about sensitive data? For sensitive data, you need to anonymize them, right? Especially names or other things. So there is a node, it belongs to the Redfield extension. Redfield is a partner of 9, so it belongs to the Redfield extension, where you put as input a data table. You select in the configuration window of the anonymization node, you select the columns of the data table that you want to anonymize, and then as output, you get the same table with the anonymized column, and then on the lower port, you get the map between the original column and the anonymized column. Of course, this map has to be stored in a secret place, or has to be somehow, put in a safe place, because of course it contains the mapping to the data that you don't want people to see. So another node still belonging to this extension is the anonymity assessment node. This node provides, so basically it checks in your original data table, in your input data table, which attributes or combinations of attributes are the most risky in terms of privacy. So this node can be used before anonymization to decide which attributes to anonymize, and it can be used after anonymization to assess the risk of de-anonymization, backwards from possible a hacker. Okay. Another extension that works with anonymization is the 9 Presidio extension. The 9 Presidio extension uses the Microsoft Presidio library, and this basically it anonymizes personal identifiable information within text data. So if you have a text data and you want to pass it to AI, for example, and you don't want that AI sees names or things like that, then before passing it to AI, you pass it through the 9 Presidio extension, and then all the risky information, all the personal information gets encrypted, gets anonymized, and then you can safely pass your text onto the AI engine. Okay, another tip here is that if you don't want to, if you want to be really sure, then maybe it's better, if it's not necessary, it's better to calculate on the fly values that might be privacy covered. For example, like the age, right? So instead of saving the age somewhere, you just calculate it on the fly every time that you need it. Okay, so I'm going to skip the part about reusability. I had it only as a, how can I say, as a, just in case I was too fast and maybe I had time left, but I don't. So to conclude, again, we said that the world needs data engineering because they need high quality data. High quality means that those are data that cover the all that collect data repository, collect all the historical data that you need, collects the data from different data sources, and applies some aggregation, some transformation operation to enhance, to expose the information that is available in the raw data. And then all these operations have to be performed correctly, efficiently, and securely. And those are the 6 directions, the 6 characteristics of data engineering. So with that, I'm finished. I think I've covered everything I wanted to cover in the 20 minutes. So thank you, and let me know if there are any questions.
Thank you, Rosaria. We still don't have any open questions. Just to remind everybody, if you have some questions for Rosaria or Andrew, you can use the Q&A tab to ask. In the meantime, we also want to cover next big NIME live streaming coming for the celebration of NIME COTMs. Basically, the most valuable contributors of NIME coming together on October 7th in Berlin for celebration, and we will be awarding them during this event. You can join the live stream. It's going to be from 5 p.m. to 7 p.m., 6:30 almost Central European time. And for you, what's there? Basically, if you ask, you like one of the lucky winner basically will be selecting who's eligible to get the free pass and NIME ticket for the Spring Summit happening in Berlin as well in March. So do check out the registration page. I'm also dropping a link to register if you cannot access on the screen. Check the description. We will have a couple of really interesting panel discussions coming up, lined with the COTMs, talking about business and education, scaling with NIME, and tips and trick to NIME ninjas. With that, I think we are finished with our both the presentations. We can see a few more seconds if you have some questions. If not, please do not hesitate to reach out to Rosaria or Andrew. They'll be happy to answer with your question. We'll also have the recording available for you. Basically, it would be shared as a follow-up email end of this week. And you can access the recording if you have questions after that as well. You can again reach out to our speakers. I think we can wrap up. Thanks, Andrew and Rosaria, for your time and the great presentations. And we'll just reach out to you if you have some open questions coming in the event page, or yeah, I'll forward it to you guys.
Wonderful.
Thank
Thank
you.
you.
Thank you so much.